Copy, 200 meters. Brace for splashdown.
And splashdown. Crew 9, back on Earth.
After 9 months stranded in space, astronauts Suni Williams and Butch Wilmore returned to Earth.
Suni Williams, big smile, big waves. She, like her other crew members, now will be assisted onto the mobility aid.
What was immediately evident about their first appearance on home soil was their changed, weakened state, with many raising concerns for their well-being. The reality is, space travel, especially extended space travel, has progressive effects on humans.
Astronaut is off structure. Houston, I've lost vision.
Dramatization may not have happened.
But what actually happens?
Activities of daily living would probably be challenging for most people in this situation. However, you could put astronauts in the same category as Navy SEALs in the amount of training and discipline that they have. So they're well aware of what they signed up for. They know exactly what they need to do, and they're probably not even going to complain about it.
One such side effect is that muscle and bone mass can diminish due to the lack of gravity in space. Muscles are designed to help maintain posture, but due to the lack of gravity, they don't need to work as hard in space. The Canadian Medical Association Journal reported that muscle mass can fall by nearly 20% in 2 weeks, and by 30% on 3 to 6 month missions. Reportedly, astronaut skeletons can also be affected by the lack of Earth's gravity. For every month an astronaut is in space, experts say that they can lose 1 to 2% of their bone mass. This means it can make it more likely for astronauts to have bone fractures, and it can take longer for injuries to heal as bones can start to dematerialize and lose their strength. And it can take up to 4 years for bone mass to return to normal.
Hey guys, look what I smuggled aboard!
Homer, no!
Huh?
Contrary to popular belief, astronauts are more likely to gain weight in space than to lose it. To combat these effects, astronauts are required to exercise 2.5 hours a day while on the International Space Station. This can include squats, deadlifts, bench presses, and using a rowing machine.
We have to exercise. We have to demand that our body stay strong. And we do that in various exercise equipment here on the space station, including T2, treadmill number 2, the Terminator, right here on space station. Time to exercise.
Furthermore, according to NASA, the agency ensures that astronauts have access to many nutritious foods. Also, the astronauts reportedly take diet supplements to keep their bones healthy.
I have rice with butter, some lentil soup, and grilled chicken patty. A lot of the Russian food comes in cans. This was one of my favorites. This is spicy beef and rice.
Space makes eating a lot more fun. You can turn your spoon upside down, or even let it go, and nothing's gonna fall off.
Despite this, these methods aren't 100% effective in stopping these side effects, so scientists are always looking for new ways to keep the body active in orbit, even down to researching jumping mice.
There is good evidence that astronauts, even after a period of a few months, experience the very early signs of osteoarthritis, and that is known from blood tests. So even if they spend more than 2 hours a day working out, doing running on a treadmill, biking on a stationary bike, and doing weights, that is not helping. So we need to find something else. So we got very promising results because with the increase in cartilage thickness we saw is very significant, thickness and volume. There is also a positive effect on bone density, which was expected, but it's good that we also saw that happens with our kind of training.
Another side effect of space travel is on human eyesight, and the effects can happen only after 2 weeks in orbit, with the risk increasing over time. According to NASA, in space, blood can accumulate in the head more than normal, which can reportedly increase blood flow problems and increase the risk of blood clots. It can also cause fluids to pool in the back of the eye near the optic nerve, and can potentially cause changes in vision, decreased sharpness, and structural changes.
The structure of the eye changes in zero gravity. There's a phenomenon related to spaceflight called spaceflight associated neuroocular syndrome. SANS is what we call it. Some of it is indicated by wrinkling of the retina. And so we're constantly evaluating each other's eyes. We have different devices on board, like an OCT where we can examine each other's eyes and see how we're doing. I did bring some reading glasses along just in case my vision shifted, then I could still be able to see the displays in the spacecraft.
Galactic cosmic rays and energetic solar particles can also cause problems with astronauts' eyes. On Earth, humans are protected by the ozone layer, but in space, cosmic rays and solar particles can hit an astronaut's retina and optical nerves. According to NASA, some of these changes will reverse in time, but others will be permanent.
When they return to Earth, they're going to notice the problems that have been added to the general physical challenges.
On return to Earth, astronauts have reported disorientating side effects, such as within the inner ear, which can affect balance.
Biggest thing that happens when you come home is your vestibular system, your inner ear, is not synced up to what your eyes see, because in space, your inner ear basically shuts down and all of your cues for orientation are done by your eyes. But when you get back home, now this data from the inner ear is conflicting a little bit with, the eyeballs. And now you're thinking, okay, am I upside down or right side up? I mean, if you're walking in a straight line and then you start taking a curve, you could just fall over because you're trying to figure out what orientation am I in.
After time in space, astronauts are required to undergo a progressive 45-day post-mission recovery program, in which the crew will have medical and performance testing, participate in studies, and follow a structured reconditioning program, which involves 2 hours every day with trainers, working on a personalized recovery plan to work back towards the fitness levels they had before they had left on their mission.
They'll be lucky if they can even get to maintenance calories. Their digestive system has been so compromised and they haven't been able to eat a lot. Gravity is required to really pull food through your digestive system.
However, further advancements are likely needed if Elon Musk gets his way and humans go to populate Mars.
Well, I think we'll have tremendous breakthroughs when we establish a city or a base and then a city on Mars, because we'll have to overcome so many challenges that it'll serve as a forcing function for the development of new technologies that will have tremendous benefits to people on Earth.
Get your ass to Mars. 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 Get your ass to Mars.